4-2, measuring angles in triangles. I think most of us already know that the sum of all the degrees of a triangle is 180. We mentioned that yesterday. And so that's one thing we can use to find out any missing angles as long as we have enough information. So in example 1 here, we know that if we're trying to find the one that's missing, well, it'd be quite simple enough. We know that 80's been used up and 40's been used up. So if I add those two together, we know 120 degrees have been used up. And if there's 180 degrees total, subtract and we find out that the last one is 60 degrees. Pretty straightforward. That one's not too difficult. But sometimes, depending on what information you're given, it can get a little bit more complicated than that. And what comes in then is the remote interior angles and exterior angles do actually work together. And basically what it says here, the sum, again, sum is the solution to an addition problem of the two remote interior angles is equal to the exterior angle. And I got a little picture here for you that shows you that these two would be the remote interior angles, these two here, if I'm talking about that exterior angle. Obviously it's called an exterior angle because it's on the outside of the triangle. And obviously every triangle has 3 interior angles. These just happen to be the two that are basically nowhere near that one. That's why it's called remote interior angles, because when you use your remote control for your television, it means you are controlling the television from a place not next to the television, somewhere far away, normally. And so in this case, what this is saying is all I would have to do is add those together, and it would give me that answer. Well, let's see if that makes sense. If this is 60 and this is 40, that's 100 that's been used up for the inside of the triangle, which means this would be 80 degrees left over for if we just looked at the triangle. And these here form a linear pair that we learned earlier this year, and so those do have to add up to be 180 degrees, and so we know that that actually makes sense, that that'd be 100 degrees over there. It's just a shortcut, and sometimes what you're going to want to do is use that because sometimes they'll put algebra in there, and so we won't be able to do it as we did this one. Okay? So any two remote. So obviously the next picture is just making sure that you understand which interior angles would be remote for which exterior. So we'll do one together and then I'll give you some time to do the other two on your own. So it says name the exterior angle associated with the remote interior angles 1 and 2. So if I'm talking about 1 and 2, I agree they are interior angles as it says here, but to make them remote I've got to find which exterior angle are they nowhere near. Well, 6, they're kind of close to 6, they're kind of close to 5, but 4, they're nowhere near. So we can just say angle 4. So go ahead, take a second here, and try and figure out the next two. All right, hopefully that was enough time. If not, just tap the screen, take a little bit more time. It says name the two remote interior angles associated with exterior angle of 6. So now we're talking about this one. We're saying which of the interior are nowhere near it. Well, 1's right next to it right there. So the two remote must be 3 and 2. So angle 3 and angle 2 are the two that are associated with it. And the next one says name the exterior angle for 1 and 3. So let's see what we can do there. So we're looking at 1 and 3. Well, it can't be 4 because that's an exterior angle that's right near. It can't be that one, so it must be angle 5. Okay. Hopefully there's no questions on that. So we know the triangle adds up to 180 total. We know 2 remote added together would give me the exterior angle that goes with it. And let's see what else we've got here. The acute angles of a right triangle. What's a good word for that? Let's take a look. Right triangle. We know it's 90, so what can you tell me about those two? Well, we know they have to be acute, but we actually know more than that. We know that they must add together to be 90 degrees, because then that would be 180 total, and the word for that is complementary. Because that's what it means for two angles to add together to be 90. Ooh, sorry about that. There can be at most, so this should be the word there. All right. can be at most how many right or obtuse angles in a triangle? We talked about that yesterday. Can you have 2 right angles in a triangle? Or can you have 2 obtuse? No, the most you can have is 1. And hopefully that makes sense. Well, why don't you take a look at this example and give it a shot, see what you can come up with. I'll give you a little bit of time to try it. There's many strategies that will get you to the answer, so why don't you give it a shot. All right, if anybody thinks they have the answer to X, you can go ahead and shout it out right now, and then we'll see if you are correct. All right, many strategies you can use. Let's see if you're right. What some people do is they look at this triangle over here on the right side. They got 105 and they've got 37. They've got that much used up. And then they do the math because they know that's 142, and they realize that this has to be 38 degrees, which is very helpful because if you remember from vertical angles, this also has to be 38 then, because it's where the 2 intersecting lines come together and they have to be congruent. And so then you look at the left triangle, we got 38 used up and 63, which is what, 101? Between those two is 101 degrees, which leaves 79 degrees for angle X. So if you said 79 degrees, good job. Another way that you could have looked at that, it would have worked out very similar, is that these are 2 remote interior angles. So if I add them together, again, it'd be 142, and that could go here. Or technically it could go here because they're both, if you kind of draw it like this, you know, they're both exterior angles of that particular triangle. And they would both have 105 and 37 as the remote. And then at that point, you know, 63 plus something also has to be 142 because 63 and X are also remote to 142. And it ends up being, at that point, you find out that it's 79. So either way it works, but you did not need the remote interior angles for that one because, again, it's all numbers. Like I told you earlier, the time where it really comes in handy is when algebra starts being put in there. And you had to know that it was coming eventually. So we've got 9x minus 13 is exterior over there, and the x plus 23 and the 6x minus 2 are interior, but they happen to be the 2 remote. So we're going to add those 2 together. Here are the 2 remote interior. So we're going to take x plus 23, and we're going to add it to 6x minus 2. We're going to add it together. It has to equal, again, putting these together will equal that exterior of 9x minus 13. So on the left side, I have a 1x and a 6, and I have a 23 and a negative 2. So the 1x I can combine with the 6x right here and get 7x. 23 minus 2 is a positive 21. Okay, so here's again where all that algebra comes in. I like to move the smaller of the 2 variables. Again, not the only way it can be done. These cancel. The 21 is still there. The equal sign is still there. 9x minus 7x is 2x minus 13. And a lot of ways you could finish again, but we'll do the way that we normally do, which is add 13 to both sides. This is getting kind of low, so I'll move it up over here. It is, what's that, 34 equals 2x. And now again is where you would like to divide by the 2. And so x is, because these cancel, 17. And this problem just says determine the value of x. So not too bad. Now, on the very bottom of your sheet, it says, now go back to examples 1 through 4 and classify each triangle by sides and angles. So just to solve this problem, I didn't have to actually substitute the 17 back in, but to find out what kind of angles we're talking, because you don't want to just kind of assume what's going to happen there. You got to actually substitute it in. So if we put 17 right in there, you take 6 times 17, and you subtract 2. And let's see, 6 times 17, what's that? 102. Subtract 2 is 100 degrees. All right, and then if we put, let's see, 17 in here, we get 40 degrees. And then over here we also get 40 degrees. Ooh, that's an interesting situation there. We have two angles that are the same. So if you classified this one incorrectly, that would be okay, but if those two angles are the same, the sides opposite also would have to be the same. And so we can know that this is obtuse, and that's classifying it by angles and isosceles. That's an S. Is by sides. Okay, so now we got to do the other ones. Well, if that's 63 and that's 79, we had 38 in there earlier and 38 over here. So this one on the left is acute. And if all the angles are the same, all the sides are the same, so scalene. This one over here, once again, all the angles are the same, so it'll be scalene. That's by sides. And obtuse because of the 105. I know the angle doesn't look that way, but looks can be deceiving. Don't have any there. Can't really classify that one, so we'll skip that one. But we can classify this one right here. This one is 6048, so this right here is acute and scalene. And we can actually do one more. Well, if we gotta get scalene because all the angles are the same, so all the sides will be the same. And acute because of that. And this is the same answer, acute and scalene.